Hello, my friend. Welcome to TubeU channel. Lately, the utilization of QR codes, also known as quick response codes, combined with stable diffusion to create artistic and scannable QR codes, has been gained popularity. I have been conducting extensive research and experimenting with various methods to find the most effective techniques. Through deep learning, I have discovered intriguing insights into the original history of QR code invention, the principles behind QR code generation, and the methods for their aesthetic appeal. Today, I'm excited to share my research findings with you. Let's get started. Firstly, there is no secrets inherent in QR codes themselves. I have acquired knowledge primarily through online sources, and most of it is straightforward and easily understandable. I delved deeply not only into the origins of QR codes, but also explored their practical applications and insights from other users. Secondly, I have employed a novel approach that I haven't come across elsewhere. This method simplifies mathematical considerations involved and streamlines the process. By employing simple operations within specific software, everything becomes visual and manageable. Lastly, it is essential to note that the final appearance of a QR code depends on your preference, not the QR code generation process itself. Quick response QR codes are among the most recognizable type of 2D barcodes. Originally developed in 1994 by Masahiro Hara of the Japanese company Denso Wave, QR codes possess the unique capability of encoding Japanese kanji and kana characters. A QR code consists of three large squares, positioned at the three corners of the barcode image. These squares are 7 by 7 in size, and contain a central 3 by 3 square, known as position marks. These squares remain fixed. Additionally, there is a smaller square or multiple squares in the last corner. This feature allows the barcode reader to determine image size, orientation, and viewing angle. These squares are 5 by 5 with one square in the center. The 7 by 7 squares are surrounded by a blank area, and a crucial section containing error correlation information and mask patterns. QR codes support multiple levels of error correlation, each offering a trade-off between the amount of recoverable data and the storage capacity. Level A, low, 7% of data can be recovered. Level M, medium, 15% of data can be recovered. Level Q, quartile, 25% of data can be recovered. Level H, high, 30% of data can be recovered. The amount of data a QR code can represent depends on the data type, such as numeric, alphanumeric, byte encoding, and kanji encoding. Additionally, the version of the QR codes, ranging from 1 to 40, determines its overall dimensions. The total size is determined by the equation 4 times version number plus 17. For instance, version 1 corresponding to a 21 times 21 square, while version 2 is a 25 times 25 square. The maximum numeric data capacity of a QR code is 177 times 177 square, which can hold 7089 digits. As for alphanumeric data, the maximum capacity is 4296 characters, and for kanji characters, it's 1817. Each square in the QR code is referred to as a module. For standard laser printers or thermal printers with a resolution of 300 dpi, each dot size measures approximate 0.085 mm. A Denso Wave recommends using a configuration of 4 or more dots per module for stable operations. With the 5-dot configuration, the module size becomes around 0.42 mm. In the case of a version 1 QR code, which is a 21 by 21 square, it measures 8.8 mm by 8.8 mm and can contain 41 numeric characters, or 10 kanji characters. It is truly remarkable how such a small area can hold so much information. Moreover, for higher quality printers, like those with 600 dpi or even 1200 dpi, the smallest QR code size would be 4.4 mm or 2.2 mm respectively. Most importantly, QR codes incorporating error correlation functions, meaning that even if a part of a QR code is damaged, it can still be recognized accurately. Here is a sample of a name card used for hospital registration, where you can observe that the QR code is much easier to read compared to a normal homepage URL link. When it comes to QR code readers, most iPhone or Android devices have numerous free applications are available. For my testing, I will use an iPhone X. During the process of reading a QR code module, the reader doesn't need to recognize the entire area. Instead, it focuses on the center part, which can be optimized using various mathematical models. I won't delve further into this topic, but I'd rather explore manual methods for achieving the same result. This concept explains why the module doesn't need to be square and can instead be round. This characteristic remains consistent for QR code scanners and QR code apps. Additionally, thanks to the error correlation feature, we can add images or other information to the QR code without losing the data contained within it. To create a more visually appear QR code blended with an image, we require additional empty space to interpret the image. I will begin by using only 20% of the center diameter, where the center occupies 10% of the area, leaving 90% as empty space. To achieve this, you can use software such as AutoCAD, Illustrator, or others to create a QR code mask. The three corners and one additional square remains fixed, as they contain important information. In the data area, circles are used instead of square. The final mask will have this configuration. Firstly, you need to generate a QR code. There are several free QR code generators available, and I have listed some of them in my description below. For example, you can visit the website https://qrcreator.com, artistic PHP. Start by selecting single URL and enter the desired URL. Choose the largest size available and select error correlation high 30%. You can also choose between plain or dots options. Leave the other parameters as defaults. Finally, download the QR code in SVG format, which ensures that the QR code information remains intact without any loss. Now let's proceed to generating artistic QR codes using QR codes and images. As mentioned earlier, the effective area of the QR code is mainly in the center. The QR code mask we use has smaller borders compared to the original QR code. By applying this mask, the final QR code will have a significant amount of empty space, allowing us to incorporate the image effectively. To begin, open Adobe Photoshop, preferably the beta version, as it contains AI functions that we will utilize. Open the QR code file, QR code mask, and your image file. Resize the QR code and QR code mask files to 1024 x 1024 format. Copy all the layers together. For ease of understanding in this tutorial, I have named each layer Mask, QR Code, Photo, and Background. Select the mask or QR code layers and delete the empty area. Scale the mask to fit the QR code image. You will notice that they fit perfectly. Although the mask's module are smaller than the original ones, it is a good practice to duplicate the layer first to ensure the original layer remains intact. Select the empty area of the mask on the mask layer and move to the QR code layer. Press the Delete key to remove the select area. When using the mask to modify the QR code, it is important to ensure that you select an area in one layer and apply the modification in another layer. This way, you obtain a modified QR code that still remains the correct information. Save the file as a treated QR code, which is an improvement over QR codes generated by standard QR code generators. Now we have three options for further treatment. Option 1. On the photo layer, select the subject. If you are unsatisfied with the AR select area, you can press Shift and drag the mouse to add, or press Alt and drag the mouse to remove areas. Then invert the selection to include an empty area or background, and remove the entire background. Place the photo layer above the modified QR layer, and adjust the size until the QR code reader app recognizes the correct information. Save the image as Photo 1. Option 2. Place the photo layer under the modified QR layer, and enlarge it to your desired size. Since your photo contains color and not white, you will need to add a white module to fill the photo area. The color selection is also very useful. The final image will appear as described. Save the image. Option 3. For image that contains the background that you want to keep. Cover the entire area with white border. The final image will have this appearance. Save the image. For the area that need detailed information, we can use mask tools to decrease the intensity of the module image. Do not use the black. It will remove the module image completely. Use some color, such as red. It will only decrease, just as using transparent functions. Here is a comparison. Old QR codes are easily recognized by QR code reader apps. We can observe that our modified QR code image is much better than one generated by a standard QR code generators. I have also experimented with modified QR codes using SD WebUI Automatic 1111. If you are interested, I can create another video demonstrating this technique. Additionally, I have some tricks that haven't been mentioned by others. I recommend trying it out yourself first. That is the best way to learn. If you are enjoying my video, please consider subscribing to my channel. Thanks for watching.